Hi, and welcome back to this second video in the fourth lecture of Covidenomics. In this set of videos, we are answering the questions of how do we value a life, how do we value a year of life, and how do we adjust our value for quality of life. And we need to do this in order to be able to put some payoffs onto the different strategies that the government can take when thinking about the pandemic. In the last video, we looked at the value of life as measured by the current or present value of future earnings. In this video, we're going to look at the value of life based on economic decisions, called Value of Statistical Life. And the way that we do that is look at what we call willingness to pay measures. Now, there's two ways we can think about that. We can look at how much is an individual willing to pay to reduce a risk to their life. That's going to be our first approach. And the second is going to be sometimes called a social approach. How much are governments willing to invest in policies that reduce the risk to human life? And we can use both of those to come up with a measure of the value of a human life. First thing we need to note, though, is that we're working on this value of a statistical life. What does that mean? Well, we're not going to work out the value of a particular person's life. What we're doing is we're trying to put a value on a hypothetical young adult, and I put young in inverted commas because when this was being developed, people lived significantly shorter lives than they do today, but a young adult with about 40 years worth of life ahead of them. And our key input to this calculation is going to be various measures for the value of life from real-world situations. And there's a range of ways we can get this input. One is to ask people to do surveys where you ask people, look, here's a potentially risky situation. How much would you be willing to pay to avoid that risk? But you're asking people about hypothetical decisions involving risk. That's probably my least favoured approach because we know that people are really bad at answering hypothetical questions. It's much better when they are actually faced with a real world risk and have to put their own money on the table. One obvious place where people really have to put money on the table is when they're buying insurance. So one form of input that comes from the market is the price of insurance contracts. However, insurance contracts are really not about the value of your own life. You don't get your life back. It's more about passing on money to other people if something goes wrong. So a better way is to look at markets where you can buy safety by paying a bit more and then seeing what people are willing to pay for a reduction in risk to their own life. An obvious place to look for this is in automobile safety. Cars are much safer today than they were even 10 or 15 years ago. And governments around the world require that certain safety features are included on cars that are sold in their countries. But almost every country, there is the possibility for a buyer to pay more and get additional safety features that may protect their life. For example, to get automatic stopping on the car so that they're unable to run into a stationary car in front, to get features that require the car to stay in a lane, to get things like adaptive cruise control and so on. We know that those safety features help reduce deaths. So we're able to use the fact that there is a market for these safety features, you can pay more and get these safety features, and look at how that reduces the likelihood of death. Of course, those same safety features do other things like prevent your car getting crumpled up, even if you know you're going to survive. So you have to use some sophisticated analysis to pull out the life part of it from other effects of these features. To see how this works, let's suppose that we've got market data that tells us that an average person is willing to pay $500 for a motor vehicle feature that reduces the probability of death by 0.01%, or in other words, 1 in 10,000. So in that case, we can say that the value of statistical life from this data is given by the $500 that the average person is willing to pay divided by the reduced probability of death P, where here P is equal to 1 in 10,000. Of course, the really interesting question is, how do you actually get this data? How do you find out what the average person is willing to pay for that reduction in the probability of death? But getting that's well beyond this course. So for this course, we'll simply take the data as given, and when you divide through by that 1 in 10,000, you get a value for statistical life of $5 million using this particular data. Another place we can look for data is the labour market. We can look at wages because different jobs have different levels of risk. And in general, those risks are reflected in the wages. So more risky jobs will tend to have higher wages. These wage differences are called compensating differentials. And if we've got the difference in wages and we've got the difference in probability of death associated with the job that has the higher wage, we again can use that market data, just like we did for the car safety features, to work out the implied value of statistical life. Okay, so now you know what value of statistical life is. How big is it? Well, that depends. For example, in Australia, the Office of Best Practice Regulation in the Commonwealth Government puts the value of a statistical life here at around 4.2 million Australian dollars. In contrast, in the United States, a number of agencies involved in the environment and transport and so on put the value of a statistical life at around 9.6 million US dollars. That's a big difference. Unfortunately, there is no simple answer to this question, depending on exactly how you measure the value of statistical life, in which country you measure it, you're going to get very different numbers. So here's an example of a survey done by the OECD in 2012. And if you look, you get a huge variety of numbers here. You've got Bangladesh in here at an average VSL of 5,248 US dollars. In contrast, you've got Denmark looking at 13.6 million. In between, you've got Sweden on 7.6, and you've got a number of United States and Canada ones, 6.2, the one that I just highlighted there, 5.1 million, that one, 1 million, that one. So you get a huge range of these numbers. Unfortunately, that's going to happen, but it's the best we can do. So in theory, measuring the value of a human life from the individual's perspective, how much are they willing to pay to reduce risk to their own life? It sounds like a great idea, but the data problems mean that we simply can't get a simple answer to our question. It shouldn't surprise us. We're dealing with really difficult situations here. A final approach is to use a different form of input, and that's to look at actual government policy. Often government policy will impact lives, and we can use changes in policy and how much those policies cost to try and get an estimate of how much a government is actually willing to pay to save a life. In many ways, this approach makes a lot of sense. As economists, we're often advising government on policy, so it makes sense to use a value of statistical life that actually reflects what governments are willing to spend in terms of policy. Unfortunately, you get the same data problems with this as you get with the other measures. For example, in the Productivity Commission's 2020 Mental Health Report, if you look at Appendix I, they infer value of statistical life from a range of Australian government health policies. However, two things to note. Firstly, there is a big variation. So we're talking about a variation of literally 400% between the lowest and the highest number. And secondly, all of the numbers of actual government policy come up with implied values for statistical life, a lot less than the $4.2 million, which is the official government number that's put out by the Office of Best Practice Regulation. So again, bring this measure in really just adds to the complexity. So in the last video and this video, we've been asking a simple question. How do we value a human life for economic purposes? And unsurprisingly, it's really hard. You get a wide range of different numbers. The best approach is to use a willingness to pay type measure to look at actual behaviour and infer the value of life from that behaviour to get a value of statistical life. But even there, you get a huge range of values. So what's the bottom line from our attempt to value a human life? Well, we know that it's better to put a value on than not to put a value on. We know that 0 and infinity don't make any sense. Putting a value on at least adds transparency. And whilst we've got a large range of different values, at least then we can rank policies and we can see which policies make sense, at least based on some values. And that's exactly how the Productivity Commission approached its task in the mental health report. When we did that report, we didn't simply use one value of statistical life. We used a range of values, both the Office of Best Practice Regulation and those implied by government policies. And we showed how different policy alternatives for mental health rated against those different measures. Some of them, on any basis, made economic sense. Some were more of a judgment call. But at least we're showing government where the relative benefits stack up. Now, next time, we're going to work out how we move from a value of life to a value of a life year, and then we're going to look at how we adjust for the quality of a life year, because they're all going to feed into our analysis of different strategies to deal with the COVID-19 pandemic. But that's it for now.